Welcome to What's New with AWS. I'm Jeff Barr. Before we dive in today, I want to thank you for your links and your comments. I love them all, so please keep them coming. So when I was young, I was mostly surrounded by a lot of IT folks who were a generation or maybe even 2 generations older than I was, and I think they mostly saw our field as kind of boring. The hardware itself was really dull. It was generally painted in matte gray of the cheapest matte gray paint they could possibly find. And honestly, the people I worked with, they just didn't see the excitement of the IT field. They pretty much just did their job, and they kind of looked more to the past than to the future. Now, I don't understand exactly why, but I saw IT and tech as a little bit more. I got this early glimpse of just how fun tech was. I understood that it was changing fast, always getting better and more powerful. And there was always something new, something interesting, and hopefully something that could be put to great use. So, and this was up at one of my really early jobs. And as I kind of watched these folks and saw that they didn't see IT as interesting or exciting and just their job, I think I decided to be different and figure out, well, I'm going to do my best to find the interesting parts, the fun parts. I'm going to really enjoy my job. I'm going to enjoy my career. And I'm going to do my best to actually share that energy, that enthusiasm, and make it really clear that this isn't just boring IT stuff in low budget gray paint. It's actually something really interesting and awesome and something worth really just kind of having a great time at. So in that vein, I want to talk to you about some really cool new tech. I've got a guest today. His name is Debu Panda, and Debu is the product manager for Amazon Redshift. So Debu, welcome to our show.
Thanks very much, Jeff, for having me in the show.
Happy to have you. So let's start with a bit of your background. Give me a sense of how did you get into tech? What was the attraction for you, and what was your path to get you to where you are today?
Yeah, Jeff, when I was doing my Bachelor of Science and I was majoring in physics, I was torn between physics and my passion for being a storyteller and a poet. And during my final year at the college that I was going to, called LN College, Jharsuguda in India, I got introduced to programming and computers by one of my close friends, and I fell in love with computers and programming. Then I thought, why not to pursue a degree in computers? So I applied for the master's in computer application at National Institute of Technology in Rourkela, and I got accepted to that. And rest is history. So I've been in the IT for the last 25 years, building different products in the industry as a developer, product manager, architect.
Excellent. Well, before we get into the tech side, I would actually love to hear a bit about the storytelling and the poetry. How did that fall by the wayside, or were you able to find a way to incorporate that into your job and your life?
Actually, I still have the passion for poetry and writing and storytelling alive in me. And in the last several years, I have authored the 3 technology books. And each of this book actually starts with an original story. And my passion for writing still kind of translates into technical blogs and articles. And I've written more than 50 articles. And for example, like I contributed more than 5 articles to Big Data blog last year. I've already written like 4 blogs this year itself for ML and Big Data blog. And I still write poems and and stories. And I have a YouTube for my stories, visual stories and poems, YouTube channel in my native language, Odia.
Interesting. So you managed to keep that interest in storytelling and actually use that as part of your job, which I think is wonderful. So you got your degree in computer science, it sounds like, and from there, what was your first job? How did you actually start working in the tech field?
Yeah, my first internship was in National Informatics Center in New Delhi, and there basically, interestingly, I was introduced to AI and expert systems there. That was my first job, as well as my first job in AI. And I kind of helped build a prototype for a expert system for the income tax department, where they can find out any kind of fraudulent taxpayers. And that was just a prototype. But after that, I actually jumped into the industry and started building financial applications in my first job at Indian Institute of Public Administration in Delhi.
Okay, and so ultimately you ended up at AWS and on the Redshift team. How was the move to AWS? What inspired you to do that?
Yeah, prior to joining AWS about 2.5 years back, I was a senior director of product management at Oracle, building their cloud management product. And I wanted to work with world's most customer obsessed company, and also be part of the cloud journey, and wanted to experience the scale that AWS operates, and then build industry leading cloud products that is used by thousands of customers and millions of users.
So when you say customer obsessed, what form does that take for you in your day-to-day job? What actual activities do you do that help you to be customer obsessed?
So there are several activities that I do as a product manager. So one of the first thing is that pretty much 30-40% of my time goes in talking to customers, or generating requirements from the customers, understanding their needs, and then possibly like sometimes frustrations. What are the challenges they have, and all those actually translates into product features.
I think this is so important. The fact that when we say customer obsessed at Amazon, it isn't just a buzzword that we put on the walls or on t-shirts. It's something that we just have to live and breathe and actually practice. Like listening to customers, respecting what they say, and then taking what we hear from them and actually turning those into requirements and ultimately into real features of the product.
Yeah, so pretty much like all like we do not build products just by looking at our competitors, or like engineers and product managers sitting and envisioning something. So all our features actually we start working backwards from their customer requirements. So customers may not be able to tell us, okay, they want this feature. They explain us what their challenges are, what their frustrations are, what their needs are. And as a product manager, I understand them. We brainstorm, write the requirements, and then once we have the right design, we actually go back to them, review them. For example, like the Redshift ML feature that we are going to talk about. So I spoke to almost 100 customers before even we start building the feature.
Wow, you said 100 customers?
Yeah, about 100 customers, like 95 to 100 customers. I don't remember the exact number, but it's about 100 customers. Yeah.
That's pretty amazing. So I want to get into Redshift ML in just a second, but before we do that, let's make sure our audience understands what Redshift itself is all about. So could you kind of give us the quick summary of what Redshift is and what our customers use it for?
Amazon Redshift is a fully managed, petabyte scale data warehouse service in the cloud. It is the most widely deployed, cloud data warehouse with tens of thousands of customers using it for gaining insight to their business, about their customers, so that they can improve, their customer experience, whether they can, improve their business decisions, or basically grow their company based on the insights they derive from the analytics they build on the top of Amazon Redshift.
So it sounds to me you mentioned earlier that you made the transition to AWS in part because you wanted to be customer obsessed, but also you wanted to work with something that was at large scale. And it sounds to me like you've more than accomplished that.
Yeah. So the primary reason basically I came to AWS to experience the scale that we operate, and it's not just the scale we operate, but the feedback that we like, the monitoring system, then the feedback loop that we have, so that we see immediately which customers are using our features, how they are using, what kind of challenges they have, immediately right after we release the feature.
So you get actually exposed to so many different customers and get to know them, get to know their use cases, their opportunities, their challenges, and so forth. It sounds like.
Yes, like when you have large number of customers, you have large number of challenges, and that actually have large number of opportunities that we can tap into.
Excellent. Okay, so with all that as a bit of background, and that was to me really helpful understanding what Redshift is all about and how you got to this point. Give me a sense of what Redshift machine learning is. Why did we build it? What does it do? And we'll go from there.
Yeah, sure. So when we basically talk to customer, like there are different user personas that use Redshift. So the primary persona I can say is the data analyst and the BI professionals, and then we have personas like the data scientists, database developers, all the different persona that they use Redshift to derive insight for their business. So what we heard from customers is that most of the organizations, they have hundreds or thousands of users who know SQL. They understand their data well, but these organizations do not have enough people who actually know machine learning and then use machine learning with their applications. And many of these customers actually use SageMaker for their machine learning, or they want to use SageMaker for their machine learning platform. So when discussing this, they wanted us to, simplify the use of machine learning in context of their, data warehouse, like Amazon Redshift. And that's how basically we kind of innovated internally by providing an ability to the end users, like data analysts, an easy way to use machine learning and create machine learning model by integrating Redshift with SageMaker. So customers do not have to know Python or Jupyter notebooks to build a machine learning model. They can just write a simple SQL statement and basically build a machine learning model. So our primary tenet was ease of use or simplicity.
Okay. So to me, when I think about this, what I hear is we've got customers that already have a lot of really business critical data. They say we've put a lot of energy into building this data warehouse and filling it up with valuable data. And then they're saying, well, we see the promise of machine learning. We understand there's some value there. Can we somehow get the benefit from it while not having to train all of our SQL developers in something totally new and kind of in left field compared to what their skills focus is? Is that reasonable?
Yeah. So main thing is that they don't want to retrain their data analysts, and many of these data analysts or sometimes they're also business analysts. They do not understand the complexity of machine learning, as well as they don't want to learn Python. They don't want to train them, and they want to use machine learning in context of Redshift. And also we heard from these the personas like data scientists, when they use machine learning, they have to export data from Redshift for their machine learning platform, and they didn't want to do that.
Now, when you say that the customer's SQL expertise still applies, what does it actually look like, and how does it apply in practice? What does that look like literally as I'm typing out the queries?
Yeah, so when you want to create a model with Amazon Redshift, the way it works is that you just write a SQL statement like create model, and you specify your training data. And training data could be a table, so it'll be like from the table name, or else you specify a query that to specify your training data. And you specify the column that you want to predict. So you specify the target column name, and then you specify a function, and then the name of the function that you want to specify or build your user-defined function, and that's it. So when you run this, create model command, with like Redshift ML, does the magic, you can say, but or orchestration. So what it does is that Redshift ML creates the training data for you, uploads to S3, and it works with SageMaker Autopilot to pre-process the data. Like for example, if there are null column there, for example, it kind of normalizes. So it kind of uses the preprocessors and pre-processes the data, prepares the data, and then it works with SageMaker Autopilot to run multiple experiments, and then finally finds the best model that is required, or applicable for your use case, based on your data that you have specified, the training data, and the column that you are trying to predict. And once the model is trained, what we do is that we actually compile the model by invoking SageMaker Neo. And then the compiled model gets deployed into Redshift. So then what it becomes is that your model is available as a user-defined function. So then you can, like, whenever you want to do prediction, you run a function in your SQL for prediction. So and then when you're doing your prediction, the prediction actually happens inside Redshift. The data doesn't get outside. So your data is within your VPC, you're secure and performant because you're taking all the benefits of Redshift.
Wow. So I love this because so much of what the customer already knows continues to be valuable and relevant. Their investment in building their data warehouse still stays relevant. The energy that they put into setting up the proper security around their data, that's still relevant. Their knowledge of how to write SQL queries, they're ultimately, after they've done the create model and they've got these new functions, they can distribute those to their database engineers, and they're writing queries. And the database engineers it doesn't sound like they really need to know or understand very much about machine learning. They just get these great functions that help them to do valuable things more easily. Is that all reasonable?
Yes, that's the primary persona, the primary use case, that you do not need to know anything about machine learning. And we use Autopilot, SageMaker Autopilot, to build the model for you automatically based on your data and the column that you are trying to predict. But we also help the data analyst or the database developer who are trying to become citizen data scientists, we call. They know a little bit of machine learning, so they can actually influence the training process or the create model process by specifying some additional parameters, like called problem type. So you can your problem type is a classification problem. For example, the customer use case is, let's say, whether the customer is going to be remain active or not, like customer churn prediction. So you can specify the problem type as like, say, for example, classification, and you can also specify your objective for training. So we provide several additional parameters for the citizen data scientist, as well as we have advanced parameters for the data scientist who wants to use machine learning with Redshift ML.
So let's say that our customer is, they're really happy with what they've got so far, but then they say, well, we do have some data scientists on staff and they'd like to contribute their expertise to this as well. What's their entry point, and how can they add value to this?
Yeah, we have like two different kind of features, you can say, for the data scientist. So when we spoke to the data scientist, this data scientists are tired of maintaining the pipeline for exporting their data to for their machine learning platform, and then because every time you do a prediction, you have to export your data, and then this data needs to be available for their end users, so they have to import the data into the data warehouse. So what we allow them to do is that they can actually specify the model type. Like, for example, someone is using XGBoost, like when they create the model using the Redshift ML, they can say create model, and in the algorithm type, they can specify algorithm as XGBoost. And also we allow them to specify the hyperparameters for tuning. and the pre-processors, for training. So that's the first path, is that somebody wants to use everything, with a create model command. Also, we provide ability to bring your own model. And we have two flavors of, bring your own model. The first one is that, let's say you have trained your model using SageMaker, okay, an XGBoost model, and you want to do a local inference or database inference. So you can actually import that model into Amazon Redshift ML. So the actual training has already happened in SageMaker, but you want to do the prediction in Redshift. So the create model command allows you to provide a location where your SageMaker model is, and it will basically compile the model inside Redshift and then make it available for local inference. We have another flavor, like for example, you are running some models that needs GPUs, and we do not want those models to run inside, Redshift, and you do not want to run that. So the models are already deployed in SageMaker, and there are users who are using from other part of the application, and you want to make use of that model also from Redshift for prediction. So you can actually use that as also from Redshift by Redshift enables you to invoke the remote SageMaker endpoint for prediction too.
Wow. Okay. That's a lot of flexibility. So I think I have a pretty good understanding of this so far. So why don't we actually return to our customers? Give me a sense of the kinds of customers and industries that are making use of this. And then if you can, maybe share a couple use cases as well.
So far, we are getting very good traction with our customers in the last 4 weeks since we made it generally available. So and then this actually spans across all the different industries, from healthcare to gaming to finance, as well as to, for example, job search recommendation. So let me just start with some few use cases that customers are using. There are, like, a gaming company is using this for lifetime value prediction. There are a couple of healthcare company, but one company had already deployed in their production. So the healthcare company is using for drug therapeutic use cases and prescription adherence use case. Let me go a little bit about this. So the company is using whether this drug is really going to be work on this specific patient, or else basically also they're looking at whether this patient is actually fall out of this prescription whatever they have. So that's kind of from the healthcare perspective, and there is a job search marketplace company who are basically improving, or they have already also deployed in production, and they improved their engagement rate and job recommendation by using Redshift ML, and that customer is actually using billions of predictions within minutes.
So when you talk about something of that scale, of use of billions of predictions, is that something they would do kind of interactively, or is that more of a batch process?
Yeah, so this organization is using in batch process, because the way they operate is that they update their recommendation early in the morning. And what this company was doing was, like, they were exporting their data from Redshift, billions of rows, and then running in an external machine learning platform. They were running their predictions, and they are importing that back into Redshift, and that was taking them several hours. And also they were paying for the machine learning platform. Redshift ML helped them not only reduce the time to gain their prediction, but also eliminated their cost for predictions.
Makes sense. So that really addresses what you told me earlier about the fact that Redshift does run at petabyte scale, which is amazing and super, super impressive. But in the absence of Redshift ML, that means the customers would need to extract the data, possibly petabytes of data, build their own pipelines that are scalable to deal with that, and then get, run massive numbers of, either for training or predictions. Either way, you need a pretty big pipeline, and then get those results back into Redshift. So you've with Redshift ML, it sounds like none of that is a factor, and you really get to focus on the ML part of it versus the pipelines and all the data motion.
Yes, Redshift basically Redshift ML actually help customers, eliminate their mundane task, building their pipeline and maintaining the pipeline, without compromising on the quality of the machine learning. Means because we have not built a new machine learning platform inside Redshift. We are actually leveraging industry's leading machine learning platform, SageMaker, for all their training, and I'm using SageMaker Neo for compiling this. So this is not a suboptimal machine learning platform, but industry's leading machine learning platform that you can take benefit without having to invest a lot of energy on building your machine learning platform. If you're
Sure. So when in my intro I talked about IT being really really interesting and thrilling, and this is I think what I mean, that this idea that we've got customers who've probably made a big investment in building these amazing hyperscale data warehouses. They got these petabytes of data, and then Redshift ML comes along and says, you've already got all this data. Let's find really interesting things in that data that are interesting, helpful, insightful, help you to do a better job of serving your customers, improve your business. So to me, that's pretty awesome.
Yeah, thanks. I think that's what we are hearing from most of the customers. Look how simple it is, and how they can easily, leverage Redshift ML for their use cases, such as revenue prediction, customer churn prediction, prescription adherence, drug therapy use cases, to name a few. So you have your data in the data warehouse, and we are bringing machine learning to the data warehouse.
So one of the fun things about listening to customers and then building things to meet their needs, after you do that initial round of building, they'll say, this is wonderful, thank you so much for listening, and now here's a bunch more stuff we'd like to ask for. So to the extent that you can share, what are you working on next?
Yeah, I think we are working on couple of things that what we have heard from the advanced users. That means basically the users who know more about machine learning. Like for example, they want to know the explainability or the feature importance of the columns, like which columns basically influence the training the most. So those are kind of features that we're adding to make Redshift ML much more easier to use. So that's what we've heard is that easy to use, but provide some ability to browse this from the console or from the editors. How we can make it further simple without having us to go to and then find this machine learning model in SageMaker. And like for example, what customers need to do is that they need to, if they want to find more about the model, they can go to SageMaker console and SageMaker Studio and find the models. But what we are looking to do is that provide an easy way to find that model definition from the Redshift console and link to SageMaker console. So we have some way right now. There is a command called show model that shows all the details, but customer want to see that visually from the console.
Sounds really cool. All right, well, we'll be sure to include some links for our readers so they can learn more about Redshift ML and they can get started. Debu, this has been really interesting. I really enjoyed listening to your story, learning a lot about what you do, and really appreciate your taking the time to talk to us today.
Thanks very much, Jeff. It's a pleasure. So I'll be providing some resources for the blogs and the demos.
Sounds great. All right, well, that's our show today. As always, thank you so much for watching. Keep the likes, keep the comments coming, subscribe to our channel, and we'll see you again soon.